Today, mobile is a part of our lives, and I'm dreaming that I have a mobile app that is saying to me like a navigator, when you go ahead or somewhere else, it's just your parking space in 200 meters. So let's speak about the options, how it can work. Is it satellites? Maybe, but looks so expensive. But what other means we have here? So Andrew will tell about the practical cases, how AI on edge in mobility can help to bring some light to this spot, to the parking spots and some others. Andrew?
So thank you, Yuri. You had a very good point, and probably Yuri's talk would be more clear after I would deliver this presentation. By the way, I have to check whether it works or not. Okay, good. So I'm from Promwad, and I would like to talk today about the AI on Edge and Mobility project. So what is AI? It's an artificial intelligence. It's a computational technology which is used for some sort of intellectual work. So it is, in fact, this technology is based on models. The models are a multi-layered network of rather simple mathematical objects which are linked together, and the data goes through this structure and acts as a filter. So the data is filtered out, and at the output you have a correct answer. So for me, it's quite a surprise. By the way, this mathematical model, this network, mimics the action of a human brain. So for me, it was quite a surprise why human brain was selected as a prototype for this system, because as we know, it's not well suited, it's not perfect for the intellectual work. But anyway, this technology, it's quite good in drawing up inference from the patterns of data, and therefore it's very useful for such tasks as detection, classification, and tracking of different kinds of objects. The history, over the history of the AI, it has endured falls and lifts, and nowadays it's again on the rising slope. And several factors support this, I would say, the success of this technology. First of all, there are a lot of academic institutions and private companies who are working actively on the theoretical foundation for this technology. They are developing the new neural network models, collect large data sets, and create tools for mastering them. And what is important, all these results are available for the public as open source. Second, for the last decades, the computational capacity grows significantly. And the key factor is that now these capacities are available on edge. What does it mean on edge? So you have two choices how to process the data. First, you could send it to the cloud, but you need then a very high rate bandwidth for the network connection. And you are unlimited in computer resources in the cloud. But on the other hand, if you have an opportunity to process the data locally, that would really give a lot of opportunities. And currently, there are chip vendors who are capable of providing these hardware solutions. So they are building chips, which in fact are multi-computers with a processing unit, with a RAM, with bus and periphery. And these systems are very small, very cheap, very efficient. They could acquire data, process it, and then transfer to the internet. And this gives a lot of opportunities. First of all, these chips could be used in a real-time application because they are fast. As they are very small, you could install them everywhere. And as they're cheap, you could install it on a very huge number of units. And as they process data locally and send to the cloud only the results of processing, therefore they are not overwhelming the transfer of data to the cloud. So you could get a lot of data immediately from a large number of these units in real time. And this opens a lot of opportunities in various applications. So Promwad is a design house, and for the more than 20 years we've developed the electronical system for automotive, for industrial automation and consumer electronics. And we feel nowadays the needs from the clients who want to install the AI solutions in their products. And as a response to this request, we have undertaken several steps. First of all, we established the partnership with these vendors like Renesas, Ambarella, and NXP. These vendors provides for us small quantities of chips or system on crystals, as they're called now, and we could use them for prototyping, so we could verify the concepts. Also, the vendors provide us a large quantities of chips which could support the mass production of products. Then we've established the network of partners with the companies who are producing the software solutions and develop these neural network models. And in fact, we're now the integrators, and we have our own team working on verifying the technical concepts and building prototype of the system, and we already completed some pilot products with that, and I will describe them today. What we would like to have more, we would like to expand our marketing and sales capabilities in order to get more orders and requests from that side. And that's why we're using media platforms and meetups like this one. Thank you for the organizers. And we would like to present here our ideas, verify them on the audience, find new partners, and also maybe get some new ideas in collaboration with you on new application of this nice technology. And the engineers of Promwad will be pleased to work on this concept together with you. So now I'll just give a couple of examples what we've done. So these are the example on the developing components for the ADAS system. What is ADAS? It's an automotive driver assistance system. In fact, it's a bunch of sensors installed in the car and integrated via the processing unit. And among these sensors are several cameras. Some of the cameras are looking forward to the car on the road, and some of the sensors look inside, in the interior of the car, on the driver. And the neural models, they could detect the area of the face, and on that face, they could also distinguish the special key points or landmarks. And the number of these landmarks are quite high. And by analyzing the correlations or distances between these landmarks, like eyes, nose, ears, mouth, and tracking the evolution of these points, you could get a lot of information. So the first thing you could do is just to recognize who is a driver. For example, if a driver is pre-registered in the system and camera captures it photo, it could recognize who is actually this driver and whether he is granted access to drive the car. And if the camera is connected to the control units, it could disallow you to drive if you're not in a bad mood, for example, or not in a good condition to drive, or even you're a wrong person. And that could be used in the application for example, car sharing companies. What you could do more, you could analyze, for example, the orientation of the head. So also you could analyze the reaction of the eye, the mimics of a human face. You could detect whether the person is in a low or high spirit, whether he is distracted, whether he is in focus on the driving process or not. And you could collect this information in time. The data is processed quite fast. The operation time is, operation rate, frame rate is about 25 frames per second, so it's really a real-time performance. And this could be used, this whole information could be used to prevent the accidents. So if the driver is tired and the system knows about that, it could notify a driver and he would undertake some actions to prevent the accident. There are cameras which looks outside on the road. And also neural network models could detect a lot of objects on the road, like cars, pedestrians, driver signs, and obstacles on the road, and many, many other. And this system could be connected with the brakes, and it could, for example, control the cruise of the car. And there are a lot of applications in ADAS technology. What you could do more, you could combine these two data flows, one from the camera which are looking on the driver, and another from the camera which looks on the road. And you could make some correlations between the driver behavior and what is happening on the road. So again, this could give you a lot of more information. And now imagine that if you install this system on each car which are crossing over the city, and you get this information immediately on the cloud, and you could analyze it with the machine learning, for example, algorithms, which are based on statistics. That by this way you could draw a very general rules which would help you to optimize the traffic in the city, to detect which roads are more dangerous and which one are less dangerous, and you could optimize the resource management for the traffic and do much more things which make our real life in the urban space easier. A very interesting approach in this technology is to combine cameras with other sensors like radars or lidars. These two kind of technologies provide a depth information. The advantages of cameras that they provide a very high resolution of the image, but they do not have the depth information, the distance measurement. Other two sensors like lidars and radars, they do provide this information. And if you fuse both this data, you could get a system with a 3D vision. And in addition, you could get the velocity of these objects. So you could, at the same time, make object detection and classification, and also measure distances and velocities to these objects. This could be applied not only in automotive sector, but also in some other areas, for example, on construction sites, or in the seaports, or measuring, for example, the volume and the mass of a bulk cargo. And these are areas where these 3D vision tools would be also very helpful. So in these examples, I have showed you the hardware which works in real time with very high efficiency, and it's consume a modest amount of power, up to 5 watts, I think, per device. We have another hardware which is much cheaper, and it has maybe not a high performance, but for some application we could afford this. But at the same time, these chips, they consume very little power, less than 1 watt. And Yuri already provided the example what are the problems of the huge city. And we have tried to solve, partially at least, this problem. So this project deals with the such-called Nielsen concept. Maybe I've heard about this. Nielsen concept is a startup for promoting the healthy life in Europe using their bikes. So they provide an infrastructure of the parking places for the bikes where a user could leave their bike for temporal storage. This parking place looks like a metallic box with a gate. And the problem is that when you are driving, you don't know whether this parking place is empty or not, and you have to knew this information. So for this project, we developed the device, a smart camera, with a Sony S-Presence system on module, which consumes very little power and costs less than $25, I think. And this smart camera has a motion sensor which acts on the appearance of the human, and then it captures the photo of this parking place and detect how many bicycles are there. And then it has a GSM module which sends this data to the cloud. So again, on the map, when you're moving on the bike and look at your smartphone, you could get the understanding which place is closer to you and which is empty. So we tested this concept and built up a prototype, and we believe that in the nearest future, this infrastructure will be really implemented in the European cities. Currently, we have the parking station, working parking station in Nantes in France. And I believe that this project would be developed and will have a good solution for this.
Andrew,
yeah.
There are a couple of questions from our audience. Thanks a lot for these wonderful slides, and I do hope that we'll extend this case study to the smart cities to finally shorten the time when you look for the free parking. There are two wonderful questions from the audience in the chat.
You could use this math of the perspective vision, and if you know the size of an object, for example, you know the average size of a car, so you could estimate the distance to the car only by its image. But again, the accuracy and the performance of this system, I think it would be lower than if you combine cameras and lidars. And the distance, again, lidar could measure the distance from 3 meters up to 150 meters, and camera would lose the resolution at this distance.
All right. Thank you so much. Guys, let's applause to Andrew. Thank you so much for this wonderful story.